Hello Spark fans and welcome back to Advancing Spark, where we're having a news day. And that normally means we're at the end of the month, and yeah, it's 1st of October. It is autumn and what is going on in the world? But that means we've got a whole load of announcements throughout the whole of September that we can wade through. So we're going to take a look at the platform release notes, have a look at the major things that have been done. There's a lot of stuff around some of the preview things, so obviously we've already talked about the release of Databricks SQL out into the wild as public preview. And we talk a lot about Delta Live tables, and there's lots of changes to Delta Live tables, just add some niceties, some maturity and all of that kind of stuff. And we've also, very importantly, got a new LTS runtime. So LTS is long-term support. That means there's a runtime that's going to last for longer than 6 months. So if you're currently stuck way back on 7.3, and you have to stick with that because company policies or library dependencies, you just can't change the runtime that frequently, then you've got a new one that's going to stick around for 2 years, and we'll have a look at what's there as well. If it's your first time around here, don't forget to like and subscribe. As always, let us know down in the comments what you think, if there's any features in here that you've been waiting for, anything that you wanted to see that you didn't see. What would you like to see in future things? Let us know. We're happy to have a convo. So, let's get on with things and see what we've got. As always, I'm in the Azure Databricks runtime release notes. So now there are AWS and GCP versions of the platform. You can go and have a look at the release notes there as well. They're largely the same. You'll see kind of the feature stack changes as a whole. The only difference is around kind of particular machine types, particular integrations. They happen on one platform, not the other. Then you'll see that, but they're largely the same. It's fine. So we're going to dive into September, see what's going on. And as always, they're in most recent first. So we're going to dive right down to the bottom and then just work our way up. The first things first. Databricks Runtime 8.0 series support ends, which is mad because that feels like it was very, very recently, but actually it was 6 months ago. Again, each runtime will only last for 6 months before it goes end of support. So that's no longer supported, which is fine. If you are currently on 8, you want to be looking at moving on, and you can go to one of the later 8.1s, but they're not going to last that much longer either. So you want to be thinking about when you can make that move up to Databricks Runtime 9.0 or 9.1, which is the new one we'll talk about in a bit. Other one, we've got PyTorch, TorchScript, and other third-party libraries that are supported in Azure Databricks Jobs. And that's specifically when you're calling Python scripts through the job. So rather than calling notebooks, rather than calling other things, if you're actually using a Python task and saying, look, there's a Python script I've got in Blob Store, go run that script, it was causing things to fail. So if you do happen to do that, they've fixed that bug, they've worked through that issue. That's not something I ever do. Something we've seen our clients do, but if you happen to be doing it, there must be precedent for it to be breaking, so go nuts. You do you. Then we've got some Delta Live tables improvements. So find Delta Live tables pipelines by name, not that exciting, just useful. Essentially, if you're on the pipelines view and you got a whole load of pipelines, similar to how they did with Databricks Jobs recently, you've now got a type down where you can type the name of the Delta Live table pipeline you're expecting, and you'll find it. Just a little bit easier. It's nice. It's not the tables the pipelines are creating, it's the name of the actual whole pipeline object itself. We can also do, now this is much funkier, so if you're using MLflow model registry, so if you've built a model, you've gone through the experimentation process and you've said, yes, I want to register that model with MLflow, we can actually now start using them inside Delta Live table pipelines. So the whole idea of Delta Live tables making engineering slightly easier, giving you an abstraction layer, rather than hand cranking all of the things that whatever PySpark or Scala or SQL is actually doing under the hood, a simplified user interface that then do the smart stuff for you. And if we can hook in to things like MLflow just to bake, machine learning into our processes without actually having to do a lot of the manual API calls, that's going to be really, really cool. So I've not had a look at what that looks like yet, but definitely a good story if we're seeing these different pieces of that puzzle come together to make a really, really simple way of engineering things and doing things like scoring it and augmenting that data on the way with ML. Fantastic. Okay, optimizations for DLT. So Delta Live tables have got 2 modes. It's either in development, in which case it won't automatically run, but when you do run, it'll leave the cluster turned on for a little bit. It won't auto terminate it until I think it's like 15, 30 minutes later, something like that. That means that if you're trying something out and you hit go and it doesn't work, you can hit go several times and you won't have to start the cluster up each time. If it's in production mode, then it's going to do things like optimize the tables for you. It's going to automatically schedule itself to run. It just automatically runs and takes care of itself. Now, previously, it would assume that you create the new DLT pipeline and it would run in production mode. And that just doesn't make sense, because if you just created something, surely it's in development until you say this is now ready. Looks like they agree. That's good. So it's now, from now on, things will be created in development mode. So if you want it to run automatically, you need to make that conscious decision to tick that box and say, yes, please, now actually run in production. But I assume that's fine because most people build a thing, then deploy and turn the thing on. So it makes entire sense to me. Okay, cluster resource usage. So it used to be very black box in terms of the clusters that actually got spun up for DLT. You could add some settings in and say, actually, no, this is the actual cluster config that I wanted. They then added it into the UI. So actually, when you create it, you can fill in some boxes about the number of workers, but you couldn't go down to a single worker. They've changed that. You can now have a minimum worker of 0, maximum worker of 1, and then that'll just run as a single worker cluster. It's not the same as a single node cluster. So it's not, I think you'll still have a driver and a worker, but just one worker rather than trying to do things on a single box. But if you've got some really small tables, if you've got like little reference tables that you need updated as a separate thing and they're just happening quite incrementally, yeah, you can do it nice and cheap. You don't need a lot of resource behind that. So you can have some nice, efficient, small clusters doing some of your work, which is all good. Okay, and pipeline permissions. Again, another sign of maturity, another sign of things just getting a little bit more enterprise ready. So if you've got a load of pipelines defined and you don't want people to be able to see it, you can say, well, you're not allowed to see it. You're allowed to view the pipeline, but you can't edit it. You could do what you want. That kind of, fine-grained permissions on the pipelines just makes sense. So now we can give people view permissions on a pipeline, but don't have to give them the whole admin access to the pipeline, which, great, makes sense. Okay, then another kind of maturity story. So feature store. So that's when it's kind of like a managed set of features that people can then build into their machine learning models. Couldn't previously delete feature tables. Again, it's the kind of features that you see after people have got all the really cool stuff and they've got it working. Like, yeah, that's great. Let's put it into production and look after it for a long time. Yeah, wait, can we delete that? Can we undo that and create a new thing? And you couldn't do that kind of stuff. So being able to delete feature tables, just useful. Quality of life. People can actually use it in anger in production. This one we spoke about. So Databricks SQL, that is the redash implementation, used to be called SQL Analytics. We saw that in a gated private preview and then in a gated public preview. And I've talked a lot about it because I'm very excited. It's where Photon first came from, and it's where the redash implementation, so the nice dashboarding stuff, went into the Databricks workspace. But you couldn't get access to it unless you had a decent use case and you said, can I get in the queue, please? This is what I want to use it for. And they go, sure, you can come in the preview. They've now rolled it out to absolutely everybody. So everyone, if you go into your Databricks workspace, you've got that little drop down. You can go to the SQL box and you can start having a play with Databricks SQL. It's still in public preview. So it's not GA yet. It doesn't have all the robustness of full production SLAs behind it. But it's at least there so everyone can try it. Everyone can test it out. You can use things like Cloud Fetch. You can try out the Photon engine. You can try out all the good fun stuff and see if that is essentially the tool you want to use to serve data to the end users from your lake. You can give it a go and evaluate it. Okay, Databricks Jobs. Again, we've seen lots of improvements for Databricks Jobs, but it used to be slightly painful if you had a load of jobs that were kind of the same and you wanted to say, well, just set all of these to a cluster, the same cluster size. Set all of these to use that one interactive cluster. Whatever you were doing in that, if you had a load of common settings, it was quite hard. You had to go and click into each one. It was painful. We've now seen this being added, which is nice. So you can see just the schedule, cluster settings, concurrent runs, all that kind of good stuff. You can now just do en masse or as a common setting across Databricks Jobs, which is nice. Okay, Databricks Runtime 9.1 came out in beta. It came out in GA as well. We'll have a chat about that once we whip through the platform features. The Jobs UI is now standard. So for a while, we've seen the enhanced Jobs UI, which was just a nicer way of managing jobs, a little bit more information, a bit of a reorg about how it's actually laid out on the screen. And then you could choose to upgrade or switch back to classic and all that kind of stuff. They've just now gone, yes, this is just how jobs look now. You can't use the classic mode anymore. You now just use the normal mode for job details, which is better. It's got more information. It's easier to use. So good. Repos. So Databricks repos is that integration. So rather than having each individual notebook and hooking up to that notebook and saying, this one's connected to Git, this one's connected to Git, this one's connected to Git. Instead, you, like any other development environment, say, I want to clone down this Git repo, I want to connect to this feature branch, and then you see all the things in there and you treat it like a folder and you can commit that folder and all that good stuff. Basically, so much better than using it on the individual notebooks thing. But it didn't have things like git ignore. So there's a load of extra files, a load of miscellaneous build files, a load of stuff that you just dumped in there for information, and you don't want that to be tracked by Git. You couldn't really do anything about it when you do it, accessing that directly through Databricks repos. You can now say, hey, read git ignore, don't bother bringing in things that are already kind of, that we don't want added to the repo, essentially. If you're adding things into your folders in the workspace, you can then add that to the git ignore and say, don't bother committing that. And it's just maturity. It's just making it closer to an actual professional IDE. So yeah, good, very useful. Azure GPUs, again, very, very Azure one, not on the other environments. There's a lot of new GPUs that we saw added into various different types of boxes. Again, that requires new drivers, requires new VM types, requires new compatibility. And we couldn't spin up a Databricks cluster to use those until now. So the new type of GPUs that we're seeing are now available as Databricks VM worker types, driver types. So if you're doing kind of like the things that need GPUs, which tend to be kind of fairly specialist, tend to be fairly niche, like deep learning kind of things, you can now actually choose those from your machine types. Go nuts. Okay, we saw 8.0 support ended at the start of the month. Towards the end of the month, we saw 8.1 support drop off. Again, because we're just hitting that 6 months after all of these things first came out. And so we're starting to see those runtimes get to end of support. We've seen 9.1 LTS, long-term support, go GA. So that is great news. As we said, if you need something that is LTS, if you need something that is not going to disappear like the 8.0 and 8.1 after 6 months, because you've got library dependencies, because you've got kind of a very, very integrated thing that's dependent on your Databricks cluster, then you can now use Databricks 9.1 as your LTS cluster. And again, got one more thing to go, and then we'll have a look at what's in that runtime and talk about those features as well. Final thing. So when you're talking about Databricks infrastructure, you've got two planes. You've got the Databricks control plane. Now that is the stuff that's managed by Databricks. That is actually hosting the workspace. It's all the stuff that's in the workspace but doesn't actually exist in that managed resource group. So if you're storing any data, I think like your users, the security mapping, all of that kind of stuff is held in that Databricks control plane. Now we could turn on encryption for it and say, actually, this should all be encrypted. I want Databricks, you guys should encrypt it on your side. I want to encrypt the stuff that's in my managed resource group in my subscription. But for the Databricks control plane stuff, we couldn't choose customer managed keys. Essentially, Databricks themselves would think of an encryption key, manage that itself, and that's all controlled in their sphere of influence. Now, if your security policies, if you're heavily, heavily regulated, if you are tied up through various InfoSec things and you have to manage your own keys whenever there's encryption for anything in your entire ecosystem, that meant you couldn't really use Databricks. It meant you couldn't use the control plane was a no-go, which is kind of one of the key points of Databricks. Now you can have customer managed keys for their managed services. So despite all their stuff still living in the control plane, you can keep the key on your side and manage the update of that and manage the movement of it. So very cool. Okay, so that's all our stuff. Now we'll have a look at that new runtime. Okay, so digging into here, we've got Databricks Runtime 9.1, LTS, we've got a load of stuff coming up. First and foremost, we have Autoloader. So Autoloader, we've seen lots of good stuff happening in. And Autoloader has had a load of things to do with schema inference and schema evolution. So previously, if we had a data frame using Autoloader, we would have to gather together a struct, gather together the actual Spark definition for that data frame, give it to Autoloader and say, this is what you're expecting. This is what you're trying to read. Now, in previous runtime releases, we saw schema inference be added. So the Autoloader instead, actually, when it first encounters a file, when we first run Autoloader, it will take a look, grab it, infer the schema, and then write that schema down to somewhere in the lake next to our data. We normally put it in an underscore schema folder in the same place as the Delta destination where it's going. Whatever, it's up to you. That was really, really good. However, sometimes it got things wrong. If the first file it gets and it looks at the customer ID and that comes through as an int, whereas we know actually when you get to the later ones, that's going to have to be a long. We're going to have some big numbers coming along. Then we could actually have to override that. And so what we could do is provide a schema hint. So we could say in the Autoloader job, here's some schema hints. And it's essentially just a comma separate list of Spark SQL column definitions. We could say customer ID long. And if when it inferred, it found the customer ID, it would then change the data type and go, oh, okay, it's not an int. You're telling me it's going to be a long. We'll use that instead. The schema hint's really, really good. If relying on Autoloader to do its own schema inference, do its own schema management, we can then just give it hints to make sure it gets the right thing. But getting to the end of the story now, schema hints did not support some complex data types. So if we're doing things like arrays, we're doing maps, we couldn't give it a hint to tell that. We just had to rely on Autoloader figuring that out. We can now do that. So if we know there are certain types of map coming, we know there's a certain structure of array coming, we can now include that in our schema hints and just get that little finer control, correcting any mistakes that we think it's going to make, build that in. So when it does do schema reference, when it builds its schema files, it's going to get it right. But kind of cool, especially if we're seeing that more and more, if we're giving more and more responsibility for Autoloader to manage the structure of incoming files, we need the ability to do that kind of stuff. So that's good. Another one slightly different. So Avro files, if we wanted to infer schema from an Avro file, essentially what it would always do is just read a single file and go, well, this is the schema I'm using. And then it would have problems if actually there were other files in that same batch that were different. So we've now got this merge schema option, which actually, it's really confusing because I always think it's the same as schema overwrite, where you're writing data into a table and you're like, merge the schema when you get there. Not what it's doing. So when it's actually working out the schema, it'll look across a load of files and then just work out what the schema is across all of those Avro files that are incoming. So if you're reading Avro files and you're suffering from schema differences between all the Avro files that you're receiving, you've now got that merge schema option you can use to kind of consolidate all of those different schemas into a single merged schema. Yeah, if you're coming across that particular scenario. Fairly niche, but you know, whatevs. Autoloader incremental listing support. So essentially, Autoloader can run in two modes. You can have the notification queue mode, in which case it just checks a queue and says, what file should I read? What file should I read? And just keeps looking there. Or you can have directory listing. Directory listing is kind of the same as using Spark file streaming natively. It just goes, what are all the files that are there? It's then got inside the checkpoint, inside RocksDB actually, inside the checkpoint, it's then got a big list of here's all the files I've written, and it goes, right, everything in that list, not in that list, that's what I need to read. That's what it normally does for directory listing. And that's slow, because that could be reading hundreds of thousands of files. Now they've implemented the new thing, which is using incremental listing. So for certain structures of files that we're reading, it can go, well, actually, because we can infer a date pattern there, we know it's any files after that point. Because they've got an incrementing number on the end, we know it's after that point. So it's a way of actually inferring, still doing directory listing, but doing directory listing in a smarter way. I generally don't see people using that much in terms of directory listing, because the whole point of Autoloader is the notification queue stuff is really, really cool. But if you happen to be getting a ton of messages and for some reason one message dead letters and doesn't make it to that queue, you're going to miss that file. Or if you stop running to fix a load of problems and you hadn't changed the timeout of messages in your event grid, and then you drop a message because it goes past 7 days, that's bad. That's not good for ETL. And so one of the things that's been implemented recently in one of the earlier runtimes was this backfill. So actually you can have Autoloader that's really nice and efficient and using the notification queue and going through, and then you can have it occasionally go, right, let's just do one big directory listing just to make sure I've not missed anything. That's a little pattern of like increment with the queue, backfill, increment, backfill. And we can now use incremental listing with that backfill to make the backfill even more optimized. So if you were looking at that and going, well, I'm not going to use incremental listing because I never do a directory listing because I'm using the notification queue, consider using the backfill just to give you that safety net to make sure there's never any data that you're missing. And the incremental listing will make that even more efficient, which is very nice. Again, maturity, things coming in. Delta tables using an arbitrary ReplaceWhere is kind of exciting. I've not had a look at how that works yet. So ReplaceWhere is a function where essentially we use it as a partition swap if you're coming from the old SQL world. And that's essentially, so if I've got a whole folder structure, I'm trying to write to a new table and that's got loads of partitions in it. Like, well, just override the data. I don't want to do a merge because I have to look at everything. I just want, this is the whole new partition. I'm going to get rid of the existing partition and put this one in its place. That's what ReplaceWhere does. So ReplaceWhere, I can say where partition ID equals this. And it just means, well, it get rid of anything that matches that partition predicate and it replaces it with the incoming data, which is nice and efficient. It means I'm not doing lookups. If I know I just want to take the new version, ReplaceWhere is super, super, super duper efficient, but it means I don't affect the rest of the table. Now, this new edition of ReplaceWhere means it doesn't have to be a partition predicate. We can do ReplaceWhere and then just pick any old value data, any old attribute, give it some kind of condition, and then it'll replace the data within that particular data set. That's not going to be as efficient because the data might be spread across all of my files, across all my partitions. It's still going to have to read it up, filter it out, create the new version of it, but it means the syntax for actually doing it is going to be a lot easier. So if someone said, we've got a big update, this particular division of my company, we need to change the value for all of this, take that data, overwrite that data, ReplaceWhere equals that division, so it'll leave all the other data in situ if it's not changed. It'll create new versions of your Parquet files in the Delta table for the ones that contained some data that has to change. Essentially, it's just syntactically going to make things easier. We wouldn't use it in the same way we currently use ReplaceWhere, which is all about performance and all about just take a partition, replace a partition. But it means you can use the same syntax to make sort of mass update jobs a little bit easier. Okay, Autoloader for GCP. Lots of file notifications. They hadn't put that stuff in there yet. So again, that's one of the big drivers behind Autoloader, so it's good to see. And it doesn't really affect us in the Azure world. Create function now supports creating table function. So we saw create function come last runtime. That was rather than having to create a Python UDF or a Scala UDF, or essentially having to define a function in the Sparky code and then register it as available in SQL, we can now just use SQL syntax to create a scalar function, or SQL, and now this, we can use SQL syntax to create a table function. So if you're, again, coming from the SQL world and you're used to creating table valued functions, you can now do that with that same functionality. Lots of different use cases for it, and because it's SQL native, then we can actually see it performing quite well. So really, really good, really exciting stuff in there. Yeah, lots going on. So from a runtime point of view, some really nice little bits and pieces. Again, no big, we've got this whole new thing you've never heard of before. It's all nice improvements to existing things that we've seen. The biggest point there is that it's LTS. This same runtime is going to be around for 2 years. It's going to expire around September 2023. And that means if you are currently on an LTS and you're waiting for the new one, this is the news you've been waiting for. And again, we should see some good stuff coming out of it. That's it. I'm aware that is a whole load of stuff. September has been a busy, busy month in terms of seeing these feature improvements, seeing them improve the previews, seeing them slowly adding maturity to a lot of this barrage of new things that we saw coming out earlier in the year. So lots of good stuff. Loads of new things that we can have a play with Delta Live tables, which is going to be my next video. And then, yeah, lots of stuff going on. So thank you for bearing with me. I know there's a lot of stuff in there, but all useful stuff. All stuff that's going to make life a little bit easier, going to speed things up, make things easier to actually manage it in production as a real enterprise system. So really, really good stuff to see. And as always, don't forget to like and subscribe. Anything in there that you found particularly interesting, let me know down in the comments. I am curious what people think whenever there's a platform release, whenever there's a runtime release. It's always good to hear your thoughts. Until next time, I'll catch you later. Cheers.